Okay, so separating into partial fractions. So I'll do the first one. Let me know if I've made a mistake. Okay, so where are we? There we go. Where is it? Where is it? Where is it? There we go. So that was your first question. 4x plus 1 over x squared plus 10x plus 25. And what I've done is the denominator, I have factorized it, and it's x plus 5 multiplied by x plus 5. Now, the questions, both of the questions are similar because you have got a repeated factor at the bottom. And when you have a repeated factor at the bottom, there is a certain technique you use to separate out into partial fractions. So what we do is we write out the first denominator as one of the factors, x plus 5, and then the second denominator as the combination of the two, which is x plus 5 all squared. So this is done only and only when you have got a repeated factor in the denominator. So once you see that you've got two of the same factors underneath, you need to have one of your fractions as x plus 5 and the other as the full expression of x plus 5 times x plus 5, which is x plus 5 all squared. Now, you've got a constant a at the top, constant b at the bottom. Now, what we are going to do, because these two denominators are not the same, what we are going to do is we are going to make them the same. So all we need to do is multiply out this factor by x plus 5, and we'll get x plus 5 all squared. But you have to do the same to the top, which is times by x plus 5. So we end up with this expression where both of the denominators are now the same. Because they're the same, I can add the numerator up, and that's a times x plus a times 5, which is 5a, plus the b, which is the numerator added up. Now that numerator added up gives you the numerator on the other side, which is 4x plus 1. And now what we are doing is we can answer this question by looking at the coefficients. So if we look, we've got coefficient means the number multiplied next to. So the number multiplied next to the x0, what I've called x0 is just where there is no x. So values that have no x multiplied next to them is 5a, b, and 1. So 5a plus b equals 1. So this 1 is equal to this expression on this side. Okay, the coefficients of x, that means that any value that's multiplied by x. So on this side it's 4. So this 4x should equal the values of the coefficients multiplied by x on this side. So ax on this side should equal 4x. Actually, I should write it out as a is equal to 4. So the value next to the x, the coefficient of x on the left hand side is a, and the coefficient of the x on the right hand side is 4, so a equals 4. So once I've got a equals 4, I can then move on to this side here because I've got an unknown of a and b. Okay, because the coefficients of just without any x, x0, anything to the power of 0 is it's 1. So this is x to the power of 1, then it'll be x to the power of 2, and so on and so on. So what we've got is 5a plus b is equal to 1, a is equal to 4. We substitute that into that expression there, and we end up with b is equal to minus 19. Now we substitute a and b back in to the original expression that we wrote out for the expansion or the expanding fractions, and we end up with 4 at the top and 19 with the minus there as well. And that's your answer. Can you double check on the mark scheme if that's correct? The other one is a little bit more tricky. I did that first. 6x squared minus x plus 2 over 4x cubed minus 4x squared plus x. Now, one of the things that we have to also look at is the denominator must be of higher power than the numerator. Okay, and that is true. So this, if you look at the highest power on the denominator is x cubed, the highest power on the numerator is x squared. Now this example, we have that already in place, so we do not need to worry about doing something different and making the denominator higher than the numerator. But we will look at that. That's a different question altogether, and you have not given me that type of question. So here what I'm doing is I'm factorizing the denominator again. I pulled out the x, and that's what I'm left with. But then I've noticed that when I factor this expression here, I end up with 2x minus 1 and 2x minus 1. So what we've got is repeated factors again. And when we've got repeated factors, we must use similar technique to what we did before. So what we've got is a over x as the first factor. And then the second factor, because we've got repeated factors, we do the same thing as what we did in the previous question, which is b over one of these factors, and then c over the combined factors of 2x minus 1 all squared. Okay, so this is a technique especially when you've got repeated factors. Okay, so now what we've got, once we've got this set up, then everything becomes more straightforward. Often the difficulty is recognizing this is how we split the fractions up. Now what we need to do is make the denominator the same. So to make the denominator of x the same as x times by 2x minus 1 whole squared, I just multiply by 2x minus 1 whole squared at the bottom. We have to do the same at the top. This one we need to multiply by x, but we also need to multiply by another factor of 2x minus 1 to get 2x minus 1 squared. So that is multiplied at the top as well. So we've got the same denominator now for the second fraction, and the third fraction, all we need to do is multiply by x to get this denominator here. So, and we do the same thing at the top, multiplied by x. Now, if we expand all of this out, because the denominators are the same, we can just add all the numerators up into 1. And this is where we have to be careful with the negative signs. So what we've got is 4a, this all expanded out is 4a x squared minus 4ax plus a. This expanded out, that's 2x squared times by b, so that's 2bx squared. And then that's x times by minus 1, which is minus x, times by b is minus bx, and then that's cx over here. Now, all of that numerator, remember, is equivalent to this numerator here. So this numerator here is equivalent to this numerator here. So we can write down and equate them together. So here we are going to look at, again, coefficients. So this 6x squared is going to be the same as all of the x squareds added up. So we've got an x squared here and we've got an x squared here. So 4a x squared plus 2bx squared is equal to 6x squared. You can write it like that, or you can write it down as just the coefficients. So the coefficient of x squared on the left hand side Just look at the x squared. That's 6. So write down 6. Look at the x squared on the right hand side. That's 4a is a coefficient, and we've got 2b as a coefficient, and it's plus 2b. So it's 4a plus 2b is equal to 6. We've got two unknowns. Unfortunately, we can't move forward from there. That will come back to in just a moment. The next one is the coefficient of x, which is x to the power of 1. That's that. That's minus 1. There's a minus 1 next to the x. So we put minus 1 here, and then we are going to look at on this side, that's minus 4a. So I'll put minus 4a here, and then I'm going to find the next coefficient of x, that's minus b, and then plus c as a coefficient for the final expression here. So we've got another expression that's going to help us in just a moment. And finally, the coefficients of x0, that means that the ones that haven't got an x next to them, so that's a 2 on the left hand side, so I'll put 2 here. And if you look across all of this, there's an a sitting on its own, no x value multiplied by it, so that's the value that we're going to put here. There's nothing else, everything has x multiplied. So here we've figured out straight away that a is equal to 2. Using that, I'm going to go straight to the first expression, plug that 2 in there, and ends up with 6 equals 8 plus 2b. Move the 8 onto the other side, we get minus 2 equals 2b. And that gives us b is equal to minus 1. With the value of b known and a known, now we can plug those in and we can work out c. So that's minus 1, minus 4 times by 2, that's minus 8. That's minus 1 plugged in there, so that's there's a negative sign here, so that becomes plus 1. So that's minus 7 here. Move it onto that side, it's plus 7. That gives you 6 for the value of c. And when I put it back in to the expression, I can see now that it is 2 over x minus 1 over 2x minus 1 plus 6 over 2x minus 1 all squared. Can you just double check that for me?